identify the sample space. The sample space is all of the possible outcomes.
Mhm.
All possible outcomes. So in this case, it's asking, well, it's another way to ask this question is, well, what color balls do you see?
I see yellow, red, and green.
Yellow, red, and green. Okay. And then the outcome is the one that's circled.
Yellow.
So it looks like that one's correct. Do you see that?
Yes.
All right, question 2 here. It says, choose impossible, unlikely, as likely as not, likely, or certain to describe the event. This spinner lands on either an odd or an even number. Um, so the wording here is really uh, troubling to me because this one's very much about your understanding of the English language. There are only two types of numbers, odd or even. So,
Yes.
so you're guaranteed to get one there, and
Hmm.
that's what this first one means. It's when you have a guarantee, it's certain.
Oh. All right. I see. Because because the arrow is pointing at an odd number.
Yeah, that has nothing to do with that. It's so that as much as I like this area of math, it's very unclear for most of the way these questions are written. So
Yeah.
okay, an experiment consists of spinning a spinner.
Hmm.
That's weird. Okay, use the results in the table to find out the experimental probability of the spinner not landing on red. Okay, so a couple of things here. Whenever you have a question that says not, you always want to ignore that. So what's the probability of landing in red? So the probability of
We
landing in red is the number of reds
8
out of the
over,
total, and you got to
yeah,
find your total here. What's your total?
30.
30. Okay. So the probability of red, if you reduce this, is 4 out of 15. Do you agree with that?
Yes.
But it wants not. Not means 1 minus your number. And it's easier to read questions when the word not is absent.
Hmm.
So if it said what's the probability of the spinner landing on red, you would say it's 4 out of 15. Not red, 1 minus 4 out of 15. Make a fraction with a common denominator.
Hmm.
You get 11 out of 15 for that.
Oh, didn't know that. So let me write this down.
That would be a good idea to take some notes while we're doing this. That way you've got them down. I will send this to you at the end as a PDF and a recording of the screen, but always good to get that down.
Okay, got it down.
Great. Okay, so the next question has some related stuff to it. I believe it uses the word not again, or no. No is another kind of word that you can associate with these sort of awkward questions. So, all right, it says a manufacturer inspects 400 personnel video players and finds that 390 of them have no defects.
Hmm.
What is the experimental probability that a video player chosen at random has no defects? So out of the 400, how many have no defects?
2.
No.
Oh, sorry, 398.
And how many do you have total?
400.
400. Great. So if you were to put that in your calculator, you would get that value there.
Hmm.
All right. These are story problems. They're a little more difficult. They are necessary for understanding how to calculate these certain things. Okay, it says that out of 200 apples in a basket, 5 are rotten. What is the experimental probability that an apple chosen at random is a good one?
Okay.
So how many are good out of the 200? And sometimes you draw a tree here. You say, oh, good.
and bad.
Bad. So how many are good? Or how many are bad?
5 are rotten, and 195 are good.
So the probability of getting a good is 195 out of the total, which is 200.
Mhm.
So that's this one right here.
Oh,
All right, let's move on to the next one here.
give me a minute. Almost done. Okay, good. Ready. Oh, ready.
Yeah, I'm just letting it
Oh,
load up here. So give me a moment here. All right, rolling, getting the first one in. All right, first question here. It says an experiment consists of 8 equal sections. So 8 equal sections means that each of these is an eighth.
okay.
Find the probability of the spinner landing on apple, carrot, or eggplant. So whenever you see the word or, you generally want to think add. And whenever you see the word and, you want to generally think multiply. These are general rules. Sometimes there's exceptions to the rules. So the probability of apple plus the probability of carrot plus the probability of eggplant. What's the probability of apple?
1/8
How about
plus
carrot?
1/8 plus 1/8, and you get 3/8.
Good. All right, so now the next one here, it says, find the theoretical probability of choosing a vowel. Hang on just a second.
be right back. Give me a minute. Hey, I'm back.
Hey, Christopher.
Hey,
Hey, sorry for the delay on that.
so the answer would be C,
Yeah, so it's like how many vowels are there? Which is
26.
A, E, I, O, and
Oh,
U. There's five vowels,
five vowels, and there's
26
26.
letters in the alphabet, and that's why it's let's see. Did you see the chat that I sent to you?
Um, oh yeah, now I see it. I didn't pay attention to the chat.
All right. So the next question here, it says, in an election, 50% of the voters voted for a new school tax. What is the probability that a voter did not vote? Did not vote. So what's the probability that they did vote? Because we never want to do the not. We always want to do the probably they did vote.
54%,
54%, and we convert that to a decimal.
which gives us 0.54.
So the no is 1 minus that number.
Uh-huh.
If are the not, we'll say not. So that's 0.46.
All right.
Okay. So then
And then
that's,
you convert that into a percentage and you get 46%.
yeah. All right. So now, the probability of drawing a green marble from a marble bag is 60%. Probability of doing something is 60%.
So what are the colons for? That's what I didn't
Yeah.
understand that.
So we're going to convert this to a fraction. So it's 6 out of 10, which reduces to 3 out of 5. Is that okay?
Yes.
Okay. So the probably the odds. This is a formula. You take this top number 3,
Mm-hmm.
okay, and the number that goes over here
Mm-hmm.
has to add up to
Five.
well, the number here plus the number here has to add up to 5. So
So
it's
two.
3 to 2. Yeah.
Yeah.
And
Oh.
it's a little bit weird because no, but we don't really like to think of odds. We like to think of well, actually, the next question is what I was thinking we do first. It's easier to go from odds to a probability.
Mm-hmm.
So um, the probability of even here, okay, because the odds are 3 to 8. That 3 goes up top, and then the
Huh?
bottom number is 3 plus 8, which is
11.
3 over 11. Yeah.
Oh, okay. So let me get that down. Wait, can you go back to the top so that I can finish up
Which
the
question?
oh, to number 4, question 4, the last one that we did. Just yeah, there we go. Okay. Okay, got it.
All right. So you got question 5 as well.
Yep.
Okay. Let me submit that. And there was one that we didn't write down correctly. Oh, I chose the wrong one for you on this last one.
Oh,
Okay. All right. So we'll go back to grades. drop to grades here, and we'll grab your so independent and dependent events. So this one either you didn't do or you well, it does say you did it, but
I
um,
didn't understand it.
yeah, okay. Okay, so the the idea of independent and dependent events, the simplest way to understand understand this is the following. So independent events,
Would be if the numbers change, or
no, you got to listen. You have to listen. This is a listening opportunity because what you said is completely not correct, and that's why I want to make sure you understand. One event does not depend on the other.
okay.
Okay, so an example of this would be like flipping a coin. When you flip a coin, you might get heads, you might get tails, we don't know. But the next time you flip it, the result has nothing to do with what occurred on the previous roll.
Mm-hmm.
If you roll a die,
Mm-hmm.
okay, if you roll a die, the outcome
Doesn't affect.
doesn't affect the like. If you get a 2 one time, you might get a 5 the next time. It doesn't matter there. The independent means that one does not affect really
The
affect is probably a better word, affect the other. Okay, so if you roll a cube, it's independent.
mm-hmm.
And then it says between these two, which of them says what we just said there as far as the answers go. Between B and D, which of these is correct?
B.
Okay, good. All right. So in the same way, when you when you have a when you have an event dependent, something that's dependent, it means that a decision affects the next decision.
Mm-hmm.
Okay. So in this example, a basketball team is being chosen. So there's a group of 20 people here. Well, after you choose one, how many people are there to grab from?
20.
So someone magically appears new again into this group.
No.
There's a group of 20 people standing here,
Mm-hmm.
and you choose one. How many are then left?
19.
19. Okay. So does the decision when you choose from 19, does it depend on how many you chose from 20?
Yes.
Yes. So these are dependent because there's fewer people to
Mm-hmm.
choose from. Okay, so then we get into some questions about how to use these, and you don't necessarily need to know whether it's independent or dependent, but what you do have to do is look at the situation, and then there's two words. Well, it's really one word. There's this word called replacement. Okay,
Mm-hmm.
so this bag has 8 football and 2 basketball cards. Well, when you pick one, there's an option. If you replace it, that means you basically put it back in. You still have 8 football and 2 basketball.
Mm-hmm.
Okay. But if you don't replace it, has this uh, bag changed?
No, hasn't.
If you replace it, it hasn't. But what if you don't replace it?
Then it has
Then it
changed.
has changed. Okay. So what is the pro? So this question asks, it says, what is the probability of selecting a football card and then a basketball card? Okay. So let's look at this situation. How many football cards are there?
8.
8. And how many total cards are there?
10.
Okay. So if you choose one, okay, if you choose a football card, how many football cards are left the next time?
7.
There's 7 football cards. There's 7 that you want. How many total are in there?
9.
Good. So see if you can multiply this out and find your answer.
Okay. I get 56 over 90, but that can reduce to... No, that cannot reduce.
What is it as a decimal, though?
Oh, 0.64.
Good. All right, so a number is rolled 2 times. What is the probability that the sum of 2 numbers will be a 9? So you're rolling a dice, a cube. I'm sorry, a cube. A cube has 6 faces, and it's numbered 1, 2, 3, 4, 5, and 6.
Hmm.
Okay. So we want the sum of the 2 numbers to be 9.
Hmm.
Okay. So how can we get there? Well, like is 1 and 8 possible?
No.
Nope. How about 2 and 7?
No.
How about 3 and 6?
Yes.
How about 4 and 5?
Yes.
How about 5 and 4?
Yes.
How about 6 and 3?
Yes.
Great. So there's 4 total.
Hmm.
4 total. Okay. And when you roll 2 die, how many possible outcomes are there? Because the probability that the sum is 9 is 4 out of the total possible outcomes.
Hmm.
Okay. So let me grab something from the internet here to help. See if I can grab one here. Yeah, I grabbed this one. All right, so here you go. How many outcomes are here?
There are 6 outcomes. Oh, sorry. There's 36 outcomes.
Yes, very good, very good. So
I
that's
thought I was looking at the purple, the stuff that was labeled in purple.
yeah. Hang on just a second, please.
No, wait. Oh, never mind. Never mind. Never mind. I thought I saw something. But wait, wouldn't that be 1 in a 9? Because this would reduce to 1 out of 9. Hmm.
Hey, Christopher.
Hey, Dad.
Christopher, sorry for the interruption.
It's fine.
We won't have any more of those. So, what did you come up with here?
I got 1 out of 9.
Good. All right, up to question 5. Oh, wait, I didn't answer question 3. I'm not doing well. Today with you. I apologize. I'll try and do better here for the rest of the lesson.
Well, do you want to just
No, we're good.
do
We're
the
good.
quiz
We're good.
later?
No, we're good. We're good. Okay. Bag contains hair ribbons. The bag. So whenever you have a bag, I like drawing a little bag.
Hmm.
And I like to write the numbers like 9B for black, 6 green, like that.
Hmm.
We're extracting all the information. We're putting it over there into a picture. It's much clearer. What's the probability of a black, then a green?
Well, the
Okay.
the black is on top and then the green's on the bottom.
No. It's let's assume somebody chooses a black.
Okay.
So there's 9
Um,
black out of how many ribbons?
15.
Okay. And then there's now 14 ribbons because you took one out. And then how many green are there?
There are 6.
6. Okay. So when you reduce a fraction like this, you can start canceling some things out. Like 3 goes into that, 5,
Hmm.
6 goes into this, so that's 2. I'm sorry, 3, and then 7. So it looks like it's 9/35.
Uh-huh.
All
Yep.
right. Got it?
Yep.
Okay. I don't understand why. Okay. Um, I got to read these more closely. This one, there was one wrong in the redo. That's because I'm not reading them very closely.
Oh.
But okay, we got one more, and then we'll do the quiz.
Okay.
How is your English paper coming along? Do you need any help finding a poem or working on a poem?
No, I'm still trying to figure out the poems. Like I'm going through them.
Do they give you ones to choose, or do you
Oh
can you
yeah,
choose any?
they give me ones to choose. Like they don't want me to choose any other ones except the ones that they give me.
All right, so I call this a bucket problem. This is a Hell's Kitchen special. All right, I'm Gordon Ramsay. I want one soup, one pizza, and one dessert. Okay, so that's where the buckets come from. Now, how many different types of soup are there?
There are wait, 5 types of soups,
2 types of pizzas, and
3 types of desserts. What's the window?
what's the window? Oh,
Like, what's
it's
our
the window.
window? Like
30 seconds.
30 seconds. Wow. Like,
Microwave your pizza
yeah, microwave it.
and pull some ice cream out of the freezer. Okay. All right. So whenever you find the total possible combinations, you end up multiplying these numbers together. That's why I call it a bucket problem. Each of these are buckets that you're pulling from.
All right.
You follow that?
Yeah.
Great. All right. How many 5-digit numbers can be formed out of the digits 0, 1, 2, 3, 4? Um,
Hmm.
this is um, I I don't like the way this is written because it's to me it's very unclear what it's asking. What you can assume is like for example are they considering the number 0, 1, 2, 3, 4 a number?
No, they're meaning like combinations.
Right, but do you see how that's like, does zero, like, can zero go in the front? Because zero doesn't go in the front in numbers.
No, it doesn't.
Right. But and like 1 0 is different than 0 1. Or maybe that's
Hmm.
a bad example. Maybe 1 2 is different than 2 1, right?
Yeah.
Okay. So in general, there's always more permutations than combinations. Especially greater than. Okay. Um, this is interesting. I'm the okay. So to me, and this is where it's I'm a little bit unsure how to even direct you, but in that first position, you can supposedly pick 5 numbers: zero, one,
Okay.
2, 3, or 4.
Hmm.
Once you choose one of those numbers, you have to choose. You only have 4 numbers to choose from.
Hmm.
Then you
And
only
then you
have
have 3,
numbers,
and
then
then
two,
2, and then 1.
1, and this equals 120
How does that equal 120?
when you multiply. You multiply these buckets together.
That's what I did, but
Well,
somehow I got it
now
mixed up.
now you have to decide whether it's permutations or combinations.
Well, there weren't
So
any
so here,
combinations. It's just permutations.
this is permutations, and the reason is because uh, 1 2 is different than 2 1,
Yeah.
so that's why it's permutations. Are you saying that wasn't correct when you did this?
Yeah, I wasn't. Yeah, I wasn't correct when like I multiplied like 1, 2, 3, and 4 like and 0, and then I just got like 0, and I just like
Oh,
put
I
in
see.
1 and 2, 3, and 4
You did something different. Okay. All right.
because it
Okay.
was unclear to
All right.
me.
So this next problem is much clearer for us. So um, okay, there are 7 singers competing in a talent show, and how many orders can the singers appear? So the first singer is going to come out on stage. Okay. How many out of this? How many can come out on? How many are you choosing from to come out on stage, or what's the sample space?
7,
7. So when they're done, when one of those is coming out on
it's
stage, do
6.
they don't go back into the pool, right? And they go down
No,
like this.
5, 4, and 3, 2, and 1.
That's right. Now, there's a name for doing this math operation, and it's called factorial. So 7 factorial, 7 exclamation point means 7 times 6 times 5 times 4 times 3 times 2
Times 2
times 1.
times 1.
3 factorial is 3 times 2 times
2
1.
times 1.
Now, do you know what 0 factorial is?
0, 1.
Yeah, it's a
What?
definition. Yeah, it's a little weird. It's an exception. So what does this multiply out to? And I'll give you a hint. It's not A, C, or D.
It's not A, C, or D.
Yeah, but go ahead and multiply it out. Make sure you confirm the number.
Okay. I get 5,040.
Right, which is what I said was B.
Yeah. You
Okay,
said it's not A or C or D.
right. Okay, so Jack orders a salad with 2 dressings for lunch.
Huh?
There are 13 dressings to choose from. How many different ways can he select a salad? Okay, so this is where it gets a little bit unclear, because you might think, well, you said, well, he chooses 13 and then he chooses 12. Well, 13 times 12 is bigger than all the numbers here, so it's not that. Well, why isn't it that? So the reason is, let's just say he wanted ranch and blue cheese on his
Hmm.
salad, and then another way he chose uh, blue cheese and ranch. Does the salad still contain the same amount of dressing on it? Like, is it?
Yeah, it would.
But see how these are? They're the same,
but there's
What?
just differences. Like they're just
Yeah.
switched.
It's kind of like this. I always my my example for this is, let's say there's a door and there's a pot of gold on the other side. Okay, and you're here and I'm here. Okay, so in a permutation problem, order matters. Now, why would order matter in this scenario if we're both going through that door? Who gets the gold based on who goes through the door? Are you there? Hello? Are you there?
Yeah, I'm here.
Okay, what's the last thing that you remember me saying?
Um, well, who has the gold? But my internet's cutting out, so I can barely hear you.
Okay, so it's cutting in and out.
Yeah, because of my internet connection.
Okay. All right. Well, the answer here is that this problem is 13 choose 2, and there's a formula for this.
Uh-huh.
There's an NCR formula for this. The formula is n factorial over n minus
Uh-huh.
r factorial times r factorial. Actually, these are lowercase. So in your problem, n is 13. So it's 13 factorial over 13 minus 2 factorial times 2 factorial. Okay, so it ends up being 13
Mm-hmm.
factorial over 11 factorial times 2 factorial. Okay, so 13
Mm-hmm.
factorial is 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1,
Times 2 times 1.
right? And then 11 factorial is
Uh-huh.
11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Do you see how these all cancel?
Yeah.
And then 2 factorial is 2 times 1. So 13 times 12, there's a 2 on the bottom, is really
Yeah.
13 times 6, which is 78.
Oh.
All right, we're up to our last question here. Mary needs to read 3 books for her English class. Her teacher has given her a list of 7 books to choose from. How many different ways can she select the books? Okay, so let's say that there's 3 books, A, B, and C. Okay, and you pick A, then B, then C. And let's say another person chooses A and C and B. Are these the same or different in terms of, like, did you get the same 3 books?
Yes.
You got the same 3 books. So notice your order does not matter. Does not
Not
matter.
matter.
Okay, so that means it's a combination problem.
Mm-hmm.
So this NCR formula, n is your sample size, basically
Mm-hmm.
what you're choosing from. How many are you choosing from here?
3. Well,
7.
you're choosing 7 books.
And you're choosing, R is what you're choosing. How many are you choosing?
3.
3. So 7 choose 3 is 7 factorial over 7 minus 3 factorial times 3 factorial. So that's 7 factorial over 4 factorial times 3 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And then 3 factorial, I'm going to write over here 3 times 2 times 1.
Mm-hmm.
So notice those 4's cancel. 3
Uh-huh.
times 2 is 6. Those cancel. And you're
Mm-hmm.
left with 7 times 5, which is
35.
35. Okay. Calculators can also do this for you. Um,
Okay.
but we're not going to use a calculator right now. All right. We should probably do the quiz. I feel like if I didn't have the delays, we could have done the quiz. But I know you can't get onto your next stuff without this. So
Yeah.
All right.
Well, actually, I'll call you after this, unless if you're busy.
No, we're gonna keep going.
No. It's something about eBay. I don't want to
Okay.
talk.
Yeah. Yeah. We can't do that here during
Yeah,
this
I know.
lesson.
Yeah.
Um, we're just gonna do these in order because there's not these don't follow like an order and well. So all right, let's. All right. Go ahead and look this over and see what you think.
Okay.
This is a not question, by the way.
Oh, all right. So they give me my fraction, which is good. I get 6%.
Okay, so what's the probability of voting for the new school tax? Like, we'll just say a yes.
Okay.
What is that?
It would be 0.4,
0.4. Good.
0.4.
Okay. So now the probability of not is 1 minus that.
Mhm. You get 0.6.
0.6. Now, we didn't cover this, but to go from a decimal to a fraction, I'm sorry, decimal to a percent, you multiply by 100. So you need to multiply this number by 100, which means moving the decimal over 2 places.
Twice?
Yeah.
Oh,
So I think you had the right answer, but I think you said the wrong answer. So
actually, I didn't know that you're supposed to. Well, I should have known that. I thought you just multiply by 10 and you get your percentage, but I
no,
guess that works.
that's 100. That's
It's
100.
100.
All right, give this problem a try, please.
Okay. I get 0.18, 0.18.
All right, that seems consistent, but we did this before, and we actually got the wrong answer. So
Whoa.
this one's a replace. So what's the probability of selecting a football card? So there's 2 football cards out of 10,
That's what
and
I
then
did.
8 basketball cards out of 10.
Oh, what?
Yeah, because you
Oh,
put it back in, so that's 16 out of 100.
oh, I got 0.1777, so I estimated around 18, even though it doesn't say to estimate, but now I see now I see the what what was wrong with that.
All right, let's snip in the next one. This is one that is from our work today, so I think you'd be able to do this.
Okay.
All right, what are you coming up with here?
Um,
Can you tell me the probability of orange?
it would be 10 out of 25
Good.
times.
Nope. That's fine. So then, what does that reduce to?
Well, that reduces to 2 out of 5. 2 divided by 5.
So not is a 1 minus.
Ah, I did it differently, but yeah, I was somewhat on the right track of what I was doing.
Okay.
But yeah, I see what I did wrong.
All right. So here's a question that's really similar to what we just did in the work today, and it's just a different number. See if you can work this out. Go back to your notes if you need to.
$24?
Yep. Did you do 4 times 3 times 2 times 1?
Yep.
Got it. All right. All right. So the next question is kind of weird. It asks for the sample space for rolling a die or a cube. And what it's really asking is, what are the numbers on the faces of a cube usually?
1, 2, 3, 4, 5, and 6.
Good. And all right. So it was actually a little bit. It was actually almost impossible to. Is this so? We'll look at the next one here. Um,
Is that one a little tricky or?
um,
Oh, okay. Yeah, so that's certain, unlikely, as likely as not. So yeah.
okay. So I've tried to clean this up because it's really difficult the way it's written. Um, what do you say here?
The spinner lands on an odd number. It's likely to, so yeah, it's 100% likely to land
What
on an
if
odd
what
number.
if it lands on 4? Is that an odd number?
No, it's not.
Okay, so how many odd numbers are there?
There's two.
And how many total are there?
4.
Okay, so what is the probability?
Oh, one half, 1 out of 2.
So which of those does it correspond to?
To certain, sorry, not as likely as not.
Yeah, that one there.
50%.
Actually, that's not right there for that number, but good. Okay. All right. All right. Well, we're doing okay. We're up to 7. All right. The probability of drawing a green marble from a marble bag is 30%. So the probability is of a green is 0.3, and that's 3 out of 10. Okay. What are the odds in favor of it? So we know that 3 goes in front, and the number that goes here plus
7.
3 is 3 to 7. Good. Okay. Now this one says in favor, and last time I think I missed the language, but it was like against, and against is slightly different, but well, you got it. You got it, and we're moving on to the next one. Great. All right. A bag contains hair ribbons for a spirit rally. So remember I said it's best to draw something over here?
Yeah.
9 black and 11 green.
11 black. Oh, yeah, green.
Okay. So Lila selects a ribbon at random, then Jessica. What is the probability that Lila selects a black ribbon and Jessica selects a green ribbon?
9 out of 20
And a 24.
times 11 over 20. 19. Yeah, that's right. Because,
Well, it's a little unclear here. Does it? It does seem to indicate that it's not put back in.
yeah, because the last time, but yeah, it does show it there. But it could be 99 out of 400, though.
Yeah, I agree that, and it should say whether it's replacement or not. But I think we're good with the way this is written.
Okay.
All right, so Anne needs 2 kinds of fruit to prepare a fruit salad. So let's think about that. Let's say you get strawberries and blueberries,
Huh?
and then you get blueberries and strawberries. Right? Is that really different?
It's permutation.
Answer my question. Are
Oh,
these
it's
different?
no.
These are the same, right? So
Yeah, they're the same.
order does not matter.
Yeah.
Okay, so permutations, order matters.
Yes.
Combinations.
Don't matter.
So which one is this?
So it's combinations.
Yes. Okay. So she has 6 fruits and she's choosing
2.
2 of them. So the formula is 6 factorial over
2
6
factorial.
minus 2
Oh,
factorial
factorial. And
times 2
times 2
factorial.
factorial.
So that's 6 factorial over 4 factorial times 2 factorial. 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. 2 times 1 here. Those cancel. And you get 30 over 2, which is 15.
Yep.
Okay, so the last one here. So there's words that go along with permutations. I haven't done a lesson on this in a while, but permutations, they generally go. We've already heard this: order, arrangements. Okay, so here we're doing flower pot, and it's basically arrangements.
Mhm.
So there's 4 flower pots, buckets, if you will, and there's 7 to choose from. So how many can go on the first?
7, 6, 5, and 4.
Okay, so this is a different. This is a multiplication problem,
So
but
42 times 20 equals 420.
close.
Sorry, 840.
Good. I like how you did that multiplication. That was really good. All right. Let's see here. Just making
Yeah.
sure we got through them all. Go ahead.
I think we didn't do number 5.
5 was the one I couldn't snip in because I couldn't fit all of the
Oh,
other questions. So looks like everything. I'm going to submit the answers, and you'll be able to move on to next week. So
all right.
um, That's great. This last one was actually a combination problem. Unbelievable. Okay. Well, I don't know. I expect you to know that.
Wow.
All right. Well, thanks again for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
All right. Bye.
Bye.